All right, in this video, I really want to acquaint you with one of the two primary vector operations that we do in mechanics, and that is the dot product. So the dot product can really be thought of as the amount of one vector which points in the direction of another vector. That is one way to think about it. And if you have two vectors, say P and Q, then the dot product between them, so P dot Q, is equal to the magnitude of P times the magnitude of Q times the cosine of the angle between them. And so if you were to look at this, then you can almost view this as if you say, okay, well, this is really like taking the magnitude of P and then multiplying it by the amount of Q that points in the direction of P. Well, if the angle between them is theta, then the amount of Q in the direction of P, if you were to drop a perpendicular down to form sort of a right triangle here, then Q cosine theta would be this little piece. And so you can think of it as, well, I'll take the part of Q in the direction of P and multiply them. But you could also think about it as taking Q and multiplying the part of P that points in the direction of Q. So again, dropping a perpendicular down here from P to Q, angle theta, then this component here is P cosine theta, and so you would have P cosine theta times Q. That's really all it is. And this, what this really means is this is equivalent to Q dot P. So I've heard it framed that this is really like directional multiplication. So it's taking the amount of one vector that points in the direction of another vector and then multiplying the two of them together. So whether I take the amount of Q in the direction of P and multiply that product, or the amount of P in the direction of Q and multiply that product, that's what I'm doing with a dot product. So here is the definition of it. And I need to show you how to do this practically. All right. Now, as far as the definition is concerned, then what this means, or the pieces that we need to consider, the formulas, are really I dot I. Well, if you think about I dot I, the magnitude of I would be 1 times the magnitude of the other I would be 1. And then the angle between the two I vectors, well, that would be the cosine of 0. But the cosine of 0 is 1. So this is 1. So similarly, J dot J is 1 and K dot K is 1. Now, you also have I dot J. Well, this would be 1 times 1, but then the cosine of the angle between I and J would be 90 degrees. Remember, I and J are perpendicular to one another. So here's I, and here's J. This is 90 degrees. And so this is 0. So this is a 0 value. If you were to take J dot I, it wouldn't matter. That would be 0. If you were to take I dot K, that would similarly be 0, as would K dot I, and so would J dot K, and so would K dot J. Now, the dot product gives a scalar value. It does not return a vector. It returns a scalar value. And these are the rules for how we actually do it. All right? Now, I'm going to kind of concise these a little bit. So I dot J is equal to J dot I is equal to I dot K is equal to K dot I is equal to J dot K is equal to K dot J is equal to 0. So what it really means is the only things that ever get multiplied are the parts that are in the same direction, which is why we call it directional multiplication. Now, as a generic example, let's take these two vectors P and Q, and let's fully populate them as if we had x, y, and z components. So we'll say that vector p is some px in the I plus some py in the j plus some pz in the k. And that vector q is some qx in the I plus qy in the j plus qz in the k. So we already know that the magnitude of this thing, p dot q, is pq cosine theta. And I use the term magnitude loosely. This thing could be plus or minus, depends on the angle between them. I'll talk about that in a minute, but let me show you how to do one of these calculations. So let's take P and let's dot it with Q. So this is going to be this vector, and we're going to dot with this vector. And when we dot, the only things that mattered were the things that had the same directions. So we're going to take the I component of px and multiply by the I component of q. So this is going to be px qx. We take the j component of p times the j component of q. And then we take the z component of p times the z component of q. And that is all you have to do. And that thing, that sum right there, is going to equal PQ times the cosine of the angle between them. Which means that if you wanted the angle between the two vectors, okay, then you could say that the cosine of theta is equal to P dot Q over PQ. So that would give you the angle between any two vectors that you had. 2 space, 3 space, it wouldn't matter. So just execute the dot product. All right, so this is a very useful thing, and that's really what I'm saying here by some of these other calculations, but I'll mention a few more. But this is how you do the dot product. Okay, you just take the corresponding I, j, and k components of each vector and multiply them together. So let me say this: if P dot Q is a positive number, let's say it's a positive. This is a scalar, so you're going to add all these together. If you get a positive number out, then P and Q tend in the same direction. And so what do I mean by that? Well, what I mean by that is that when you take the part of Q in the direction of P, okay, the Q cosine theta term here, the arrowheads point the same way. If you take P cosine theta, the part of P in the direction of Q, then the arrows point in the same direction. The two vectors point in the same direction as one another, at least along the direction of one relative to the other. That means really that theta is less than 90 degrees. Okay, because that's when cosine of theta is positive. If P dot Q is negative, then P and Q tend in opposite directions. And so an example of that, let me draw a couple of vectors here. So here's Q, and let's say this is P. Here's the angle theta. Well, if you take the part of P in the direction of Q, it points back this way. So this is the opposite direction. And so that's really all that means. So in that case, 90 degrees less than theta less than, I guess, 270. Something like that. So there's 180 degrees there. And in the other one, when it's the positive sense, minus 90 degrees is less than theta is less than 90 degrees. Now, the other thing you could do, if you were to take a dot product of a vector with itself, then you would have pxi dot px, which would be px squared, plus py dot py, which would be py squared, plus pz dot pz, which would be pz squared. So the dot product would then give to you, if you were to take the square root of p dot p, then that would be the square root of px squared plus py squared plus pz squared, but that would be p. That's how you would take the magnitude of a vector. All right, so that's a vector magnitude. So we've talked about how to get the angle between two vectors. We've talked about how to take a vector magnitude. We've talked about how to do a generic example of a dot product. There's one last thing to maybe mention here, and that would be the distributive law. So if you had P dotted with two vectors, say Q plus R, then this would be the same as P dot Q plus P dot R. That's how that would work. So you could just do the dot product of P with each vector individually, or do the sum and then do the dot product after that. It wouldn't matter. Okay, they would be the same. All right, so distributive law, we did commutative law. I think that's sufficient for what you would encounter in this course. Showed you the calculation parameters, and that's it. All right, so that's the dot product. Very useful. You should definitely know how to do it. All right, stop there.